Hi everyone, welcome back. After we've learned how to add and subtract two or more matrices together in the previous video, in this video, I'll be explaining how you can multiply matrices together. There are two ways to multiply matrices together, and there are two types of multiplication in matrices. So one is scalar multiplication. So by scalar multiplication, I mean a situation whereby you multiply a scalar by a matrix. So for example, if you have a matrix A to be 1, or let me do it in general, A11, A12, A21, A22. You understand now? So then when I have a scalar K, scalar means a number, a constant, then multiply by A. So, this matrix is, this A is a matrix. Then if you want to multiply a number known as scalar by a matrix, then you are going to multiply the number by each of the elements in the matrix. Then I'm going to have KA11, KA12, KA21, KA22. So if that is cleared, let me give you an example so that you can see what I've just said properly. Example, if A is equal to 341802, find 5A. So you can see A is a matrix and 5 is a constant. So to obtain this is not difficult. 5A will be what? 5 multiplied by this matrix, that is 341802. So then that's going to give me what? That is, you multiply 5 by each of the elements in this matrix. Then I'm going to have 15, 5 times 4, 20, 5 times 1, 5, 5 times 8, 40, 5 times 0, 0, and 5 times 2, 10. You see, it is very simple, isn't it? That's one of, the way you can multiply matrix known as scalar multiplication. So the second multiplication you'll be doing in matrices is what? Matrix multiplication. So for the first situation, we're multiplying a number or a scalar by a matrix, but in this case, you'll be multiplying a matrix by another matrix. So in essence, A will be a matrix and B will also be a matrix. So to multiply two matrices together is not difficult. So although when you are to multiply, so you will still be multiplying, but a slight difference between your normal multiplication is that before you can multiply two matrices together, then those two matrices must be conformable. What do I mean by conformable? That is, they must be defined. So in essence, the number of columns in the first matrix must be equal to the number of rows in the second matrix. For example, if you check, maybe you want to multiply these two matrices together, matrix A, let's say matrix A has an order of 3 by 2, and matrix B has an order of 2 by 3. Let's say I also have another matrix C, so that is 4 by 1. So A by B, before you can multiply it together, you have to check whether they are conformable. You check for their conformability, whether they are conformable, whether they are conformable. And to check whether they are conformable, like I've said, then you write the order of the first matrix. The order of the first matrix here is 3 by 2. Then you now write the order of the second matrix immediately after, under the column of the what? Of the first matrix. So your A is what? This is what I'm trying to say. So A is 3 by 2, then your B is 2 by 3. So if you can establish that the column of the second matrix is the same thing as the column of the first matrix is the same thing as the row of the first matrix, then they are conformable. Indeed, you can multiply them together and multiplication will be what? So we give rise to a matrix of order 3 by 3. Okay, let me now ask you, can I multiply B and C together? Don't forget, before you can multiply, they have to be conformable. What's the order of B? 2 by 3. You understand now? So order of 4 is what? Order of C is what? 4 by 1. You can see the number of columns, the column of the first matrix is not the same thing as the row of the second matrix. Then they are not conformable, not defined. So in essence, when they ask you to show whether two matrices are defined, then you have to establish that the column of the first matrix is equal to the what? The row of the second matrix. That then they are defined, they are conformable, and you can multiply them together. How do you now multiply two matrices together? It is not difficult. If you want to multiply two matrices together, then you multiply row by columns. What did I call it? You multiply row with what? Columns. You will understand now. And how do you multiply it? Let's say I have this row, maybe a row matrix. I have 1, 2, 3. Okay, let me just do one first with one row. Then I have another matrix 0, 2, 4. You know, this is a matrix. This is a matrix. Indeed, they are conformable because order of this first matrix is what? 1 by 3. Order of the second matrix is what? 3 by 1. In essence, they are defined. We are going to have 1 by 1 matrix as their product. So if you now want to multiply them together, let me just give you this basic so that if you understand it, you can apply it to like a larger situation, I mean a more complicated situation. If you want to multiply these together, then you now take the first element here, multiply by the first element here. That will give me what? 1 times 0, then plus the second element of this row multiply by the second element of this what? Column. That will be 2 times 2. 2 times 2. Then lastly, this guy multiply by this guy, that will be 3 times 4. So and this one will give me 1 plus 4 plus 12. So and that gives rise to 17. Can you see it is very simple? Okay, let's see if I have like two more columns. Let's see if I have like two more columns. Okay, 1, 2, 3. Then I have 1, 1, 0, 4, 2, 2. First, let us check whether they are conformable. What is the order of the first matrix? The order of the first matrix is what? 1 by 3. We have 1 row, 3 columns. I hope you understand now. So, yeah. Okay, what is the order of the second matrix? That is what? 3 by 2. 1, 2, 3. So that is 3 by 2. It means they are conformable. And the product of this matrix will give rise to what? 1 by 2 matrix. How do you now multiply it? Don't forget I said you multiply row with columns. You first of all multiply this guy, this row, by this column, then again the same row by this same column. Okay, let us do it. How do you do it? The same way I explained. Let's say I want to multiply this by this column. Like one of my boss used to say that if you are multiplying two matrices together like this, then we require 3 things from you so that you don't make mistake. Your eye, your ear, and your mind. So then we now have 1 times 1, 1 plus 2 times 0, 0. I hope you understand now. Then plus 3 times 2, 6. So you know you've done for the first column here. Then you still do for the second column here. Then 1 times 1, 1 plus 2 times 4, 8 plus 3 times 2, which is 6. You understand now? Then you are going to have something of this nature. I think it is proper if I can reduce this and properly rewrite it. So then you have something of this nature. This will now give me what? 7, 15. Can you see what is the order of this matrix? I have a matrix of what? Of the 1 by 2, which I've actually dictated here. So if that is clear, let me now give you the one that is more complicated. Let me give you the one that is more complicated. Example. So if if m is equal to 2, 3, 2 minus 2, and n is equal to what? 5, 10 minus 15 minus 5. Then the question asks us to find number 1, mn, number 2, nm, number 3. Then we have to show that m squared is what? 10i. So you have to show that m squared is what? 10i. This is not difficult to do. Okay, let's see. Can we multiply mn together? Before you can multiply, you have to check whether they are defined or not. So you check for their conformability. Are they conformable? What is the order of matrix M? That is 2 by 2. What is the order of matrix N? It is also 2 by 2. And don't forget, I told you before you can multiply two matrices together, it means the column of the first matrix must be equal to the row of the first matrix. I hope you understand. It means we are going to have 2 by 2 matrix. Okay, now you can place them side by side to each other. What is my m? 2, 3, 2 minus 2. Then my n is what? 5, 10 minus 15 minus 5. Remember what I asked you to do? What I told you, if you want to multiply two matrices together, then you multiply row with columns, or row by columns. So it means you have to start from here, row by columns. You have to do it for this guy as well as for the second guy. Okay, what are we going to have? And to do that, you multiply this by this, 2 times 5, 10, plus 3 times minus 15. That will give me minus 45. I hope you understand. Okay, that's you are done with this column. Then you still move to the next column. That's why I said you multiply row with columns. Then you now move to these columns again. That will give you 2 times 10, 20, then plus 3 times minus 5. That is minus 15. Oh, I hope you understand now. You can see we are done multiplying this row with these two columns. Then you now move to the second row. Again, you are still going to multiply this row by these two columns. Okay, let us start with the first columns. To multiply this by this, it will be 2 times 5, 10, multiply by b plus minus 2 times minus 15, that is 30. Okay, 2 times 10 again. We've done with this column. Then you still take the same row and multiply with this column. That will be 2 times 20, 2 times 10, 20, plus 2 times minus 2 times minus 5, that is 10. Then you can now simplify it further. What are you going to have? This minus 35, 5, 40, 30. So can you see it is very simple? Okay, let us find the second question. Asks us to find nm. And by this, we are going to see whether multiplication of matrix is commutative or not. So 5, 10 minus 15 minus 5. So then you have 2, 3, 2 minus 2. I hope you understand now. 2, 3, 2 minus 2. Okay, now, if you want to do this, first of all, check whether they are defined. Can you multiply them together? What is the order of n? 2 by 2. M is also 2 by 2. It means they are defined, they are conformable. The product of the two matrices will give rise to matrix of order 2 by 2. Okay, let us multiply them together again. Again, your n by m, n multiplied by m will be what? Eh? So you multiply the row by columns. Now, if you want to get what you are going to have in the first column here, you multiply this row by these columns. After you are done with that, you still take the same row by this column. Even if there are 50 columns, you'll be doing it one by one like that. And to multiply row by column, you just say 5 times 10, 5 times 2, 10 plus 10 times 2, 20. Oh yeah. Then the second one, 5 times 3, 15, 10 times minus 2, that is what? Minus 20. You know, it's supposed to be plus, but plus times minus will give me minus. Okay, you move to the next guy. This row with the same columns. Even if they are 30, just take them one by one. Row times minus 15 times 2, minus 30, plus minus 5 times 2, that is 10, minus 10. I hope you understand now. Then you still take to get this row, you still take the same row with this second column. Minus 15 times 3, minus 45, plus minus 5 times minus 2, that is 10. Then what are you going to have? 30, minus 5, minus 40, and this one will give me what? Minus 35. Can you see? Are they conformable? So they are not. I mean, are they equal? Is m equal mn equal to nm? You can see they are not equal because this is my mn. I have minus 35, 5, 40, 30, and your nm is just 30 minus 5 minus 40 minus 35. Then you can say that matrices cannot be what? So matrices cannot be what? Matrices, the product of two matrices are not what? Are not commutative. If that is clear, let us do the third example. We are to show that our m squared is equal to 10i, where your I is an identity, I guess. Your I should be an identity matrix. So I think we forgot to put it. We should put it. Your I is equal to identity matrix. So and my m is what? Let me check my m again. My m is 2, 3, 2 minus 2. So 2, 3, 2 minus 2. It means m square will now be what? 2, 3, 2 minus 2, 2, 3, 2 minus 2. Okay, let us multiply it again. Row with column, row by columns. So that will be 2 times 2, 4, plus 3 times 2, 6. Again, to get this column, you still multiply this the same row by this column. Don't forget, even if there are 50 rows, you'll be multiplying this row to get the columns. So 2 times 3, you have 6. So 3 times minus, that's minus 6, right? Then you move to, we don't have any column again. Then you now move to the second row. Then this guy times this guy, 4 minus 4, right? 2 times 3, 6. So then what do we call it? The second one, so we have 2 times 3, 6. Then minus 2 times minus 2, that is 4. Then what do you have? 4 plus 6, 10, 0, 0, 10. I hope you understand now. So you can see that 10 is common. You can factor 10 out. Then this will be 1, 0, 0, 1. And what is this matrix look like? It looks like an identity matrix, which is I. You understand now? Then you can conclude by saying your m square is going to be 10i. So your m square is going to be 10i. So you have to know that not all matrices can be squared. You understand now? So not all matrices can be squared. But if your matrix is a square matrix, so then you can actually, calculate it. So in essence, you can only find the square of a matrix if the matrix itself is what? Is a square matrix. If the matrix is a square matrix. Okay, what if you have, like, you want to multiply 3 by 3 together? Let's say I have my A, or let me just write it since because of the time. I have 1, 2, 3, 0, 0, 1, 1, 1, 2, and the second matrix maybe 0, 1, 1, 0, 1, 4, 0, 0, 2. Let's say I want to multiply this guy together. Let's check first. Can we multiply them together? Before you can multiply, they have to be conformable. The order of the first matrix is what? 3 by 3. The order of the second is also what? 3 by 3. It means I'm going to have matrix of order 3 by 3 because this guy, we cancel this, so then they are conformable. Okay, to multiply them, don't forget row with columns, row by columns. If you want to get this column, you multiply this row with this column. And how do you do that? This times this, the first one multiplied by the first one plus the second one multiplied by the second one plus the third one multiplied by the third one. So that will now give you 1 times 0, 0 plus 2 times 0, 0 plus 3 times 0, 0. I hope you understand now. Okay, you do the to obtain the second row, you still take the same matrix, you multiply by the second what? Second column. Then to do that, first by first plus second by second plus third by third. So 1 times 1, 1 plus 2 times 1, 2 plus 3 times 0, 0. So for the third one, again, the same row with the third column. That will be what? 1 times 1, 1, 2 times 4, 8 plus 3 times 2, that is 6. I hope you understand. And then you move to the second row. You still take the second row and multiply by each of these columns. That will be 0 plus 0 plus 0. Okay. The same matrix with the second column, first with first, second with second, plus third with third. 0 plus 0 times 1, 0. I hope you understand. Plus 0 times 1, 0. You have to be careful so that you don't make a mistake. 1 times 0, 0. And the third one, 0 times 1, 0 plus 0 times 4, 0 plus 2. Okay, then you do for the third matrix as well. 1 times 0, 0 plus 1 times 0, 0 plus 2 times 0, 0. Then the second column, 1 times 1, 1 plus 1 times 1, 1 plus 2 times 0, 0. Then the third column, which is here, 1 times 1, 1 plus 1 times 4, 4 plus 2 times 2, 4. So then if you simplify further, this will give me 0, 3, 15, 0, 0, 2, 0, 2, 9. So, and that's the product of that matrix. You can see multiplication is as simple as that. So if you understand the video, please don't forget to like, share, and subscribe. I will see you in the next video. Thank you.